everyone. Whoa, am I too loud? Okay. I hope you're having a good time at Spring.io. Spring.io is my, I think, favorite conference. I try to come here every year. Not always it works, but at least I'm trying. We are going to talk about implementing domain-driven design with Spring Boot. And not even talk about implementing, but more actually implement something by following domain-driven design principles. But before, to set the stage, why am I here, and probably also why are you here? I work as a freelancer since quite some time, and I've been working with many different customers on many different software projects, in many different code bases, and all of these code bases, or most of them, not all of them, but most of them, share one quality. They all, sooner or later, turn into smaller or bigger mess. I don't think, though, this is really our fault. I think software development is hard, and life, or rather work as a software developer is also quite difficult. On one hand, we have business people, product owners, or anyone just flooding us with user stories, issues, tickets, however you call it. We are expected to basically deliver, and we know that this is actually how we produce the value, so we try to do it, but we are under constant pressure. On the other hand, there are things that business people don't really see, like we have to upgrade to new dependency versions. We try to keep it, or at least we should, to stay as much up to date as we can, because we know that if we don't do it for a longer time, then it becomes actually a big problem. And then another thing is that because most of us adopted microservices architecture, we have a lot of infrastructure not only to create, to manage, but also to operate. And suddenly, we are not only Java developers, we are not only implementing applications, but we also have to know all the microservices-related technologies. So we now tackle the Kubernetes construct. We write Terraform, we have to know the cloud. And it's not only time-consuming thing, but it's also very often a soul-sucking experience. At least I have never seen a Java developer who would be happy to write a new part of Terraform script. And on the top of that, we have Scrum and Agile ceremonies, where sometimes they are fun, but usually they just take our time, and we are sitting at these meetings and wondering, is this the job that I actually wanted to do? Okay, and the problem is that we are just busy, right? We don't have time, and we don't have time to properly design software. I think that we are so busy with doing all the other stuff that the thing like software design actually went away. So, I think we should take a step back, and instead of spending so much time and effort on implementation and infrastructure and all the things that you could put under the details umbrella, and take a step back and think about how can we design the software better. Over 20 years ago, Eric Evans wrote a book, Domain-Driven Design, Tackling Complexity in the Heart of Software. So this is exactly the book about software design that basically is, even though it's like 20 years old, it's relevant till today. And in this book, this is what it exactly says: how to design a software for a complex domain, so how to design a complex software for a complex domain that in the end does not turn into a mess. Maybe a little bit surprisingly, maybe not, he doesn't say that it's an architecture. It's actually a design. And there is a thin line between what is a design and what is an architecture, and people argue about the definition. I will not try, because why would I? I will quote Martin Fowler on this subject, what the domain-driven design is. And domain-driven design is an approach to software development that centers the development on programming a domain model that has a rich understanding of the processes and rules of a domain. So to emphasize, this is an approach to software development where we are going to program a domain model based on our understanding, right? So this is like just a different way of thinking about software. So now our main job is to develop this domain model. Domain-driven design touches a lot about organization, how organization has to change, how we all have to change the thinking to produce actually a big software. It's not like we can do it only by ourselves, developers, but some of these parts of this book, like a big chunk of this book, is actually also for developers. So just to distill, what does it mean for developers? First of all, we have to understand the domain. This means that if you want to build a good banking software, unfortunately, you have to understand banking. And the only way to understand banking is either learn about banking, and I don't think we really have time for that, but the other way that is also quite reasonable is to talk to people. So we would have to talk to people who are as close as possible to the banking problem. So these could be bankers, this could be maybe project managers, maybe this could be product owners, depending on how close we can get in our organization. But we have to do the thing that we don't really like to do much, which is talking. So, once we more or less have an understanding of this domain is usually complex, right? Because we are talking about building the complex stuff. So, complex domain is difficult to tackle at once, so we should split a problem into smaller problems and then tackle them independently and then somehow make them work together. Then we have to develop a ubiquitous language. Who knows what ubiquitous means? There are quite a few hands. For me, this is like a complete bizarre word. I don't know. They didn't, teach me this on English classes. Ubiquitous language is the language that is everywhere. So when I say develop, I don't actually mean that we have to write a code or anything like this. It's about creating this vocabulary that we agree on using, that our bankers use, our project managers use, our product owners, we write user stories using these words, and then also our code is written using these words. So probably most of this language will come from bankers or from the banking domain. So we try to adopt the language that they use into our code. So if they use certain nouns, we will create probably classes with the same nouns. If they use certain verbs, maybe we will create methods. It's not like exactly one-to-one, but I think you get the point. So our user stories, our code, everything is more or less should be understandable, and thanks to that, we close the gap between what these guys are talking about, what they want from us, and what is into our code. We should reach the level where we could show the code to a banker, and the banker should know what is happening there. I don't know if this is really possible, but that's the goal. We don't have to, it's good to have direction, not necessarily we have to achieve these goals. All right, so when we have this understanding of the domain, we actually develop the domain model. So this means that we write the code that reflects what we learned about the domain, and there is like a small asterisk. This domain model should be separated from the implementation details. So we should use as little to zero things related with the infrastructure, with frameworks, with databases, and so on. Domain model should stay pure. If we use Java, it should be written in Java. So there is this blue book that Oliver Drotbaum calls the Old Testament, and then 10 years later, there was another book released, which is called, Oliver calls it, but I like it. It's called the New Testament. So 10 years later, around 2013, there was a book about implementing domain-driven design. I mean, somehow sounds familiar. So there you will see how to actually turn the ideas from the blue book into practice. And even though this book is 10 years old, the examples are written in Java, and maybe surprisingly, but most of these examples will work even now, right? So it's like a still completely valid position to read. All right. When we develop software, usually, we have to focus on many different things. The things that we are most excited about are the frameworks, the technology, right? So that's why we are here. We want to learn about Spring. We want to learn about new cool features, new, better ways to do REST clients, maybe a better ways to do persistence. And then there's this like one part of our job is implementing the business logic, and it's like, we put the service classes and just like one small piece of application. If we adopt this domain-driven design thinking, we have to focus our efforts on developing the business logic, or how we will call it now, it will be a domain model. So domain model is the king. Everything else, let's say, centers around it. But what this domain model actually is. So the domain model encapsulates the domain knowledge, domain rules, processes, constraints, behaviors, state changes. And I can imagine that it still is not really something that it's easy to translate in your head into the code. So both of these books tackle the topic of tactical design, and they present certain tactical patterns. So the actual building blocks that you can use to develop the domain model. And some of these you are probably familiar with, right? So there are entities, repositories, aggregates, factories. They all sound maybe somehow familiar because they are also used by other approaches, maybe in a little bit different context, but at least it somehow should ring the bell. Once we have developed this domain model, the domain model is pure, right? It's not framework related. So we can't just deploy domain model to production and make people use it. We have to somehow build something around it that we actually form an application. There's no one way to do it with domain-driven design, as domain-driven design is really about designing the software and the domain model, not about the implementation. But it seems like that the community standard to implement domain-driven design is to use either onion/hexagonal/clean architecture. All of these three approaches are quite similar, but most importantly, what they share is that the domain model is in the center, and the dependency arrow points towards, forwards, inwards, to the inside. So there is a domain model that has no dependencies on anything else. Then there are application services that act as an entry point to our application, and they can use the domain model. And then we have a user interface, delivery mechanisms like web APIs, Kafka listeners, and so on, that will interact with the application services. The thing that could be maybe slightly interesting is that the infrastructure, which in this case would be persistence, the databases, the layer that talks to the database, the layer that talks to caching mechanism, also depends on the application services domain model, not the other way around. Okay, so this would be pretty much enough talking, because this presentation is about implementing domain-driven design and not talking about the domain-driven design. The subject of domain-driven design is so big that it's not possible to cover it in one short talk, so I will not give even an attempt to do so. We are going to take like a relatively simple example, very simple domain, probably too simple to actually, even focus on. Maybe not. Maybe it's not that simple. Anyway, so we will try to implement a software for a library using this domain-driven design principles. But before we do so, I will show you how this software was implemented by, let's call it a traditional approach. The patterns and the approaches that I see very often when I see some code bases. Is this big enough? I guess it's not, right? No? Okay, maybe let's do it like this. So this is a library project implemented with the YOLO domain, YOLO design, let's call it. When we open the package structure, we will not actually know what this application is about. We will see that it's split by some technical responsibilities. We see this package of DTO that I'm really afraid to look into it. There are some entities, so this somehow reminds, well, maybe this has something to do with domain-driven design. But when we look inside, you will see that these are just some JPA entities with some spice from logbook, and these are just mutable data containers. And the same applies to all of them. Then we have repositories, which is also a concept from the domain-driven design, and then we have services and some utils classes. So if we want to try to find out what is happening in this application or how we can use it, we basically go to service classes. So we go to the book service, and we see that there is a method add book. So probably if you want to register a new book in the library, you will call this method. But there is this book management service that looks a little bit maybe interesting. Management sounds serious, and it also has a method add book. And now it becomes a little bit confusing of which one should you use. What is actually the responsibility of these two services? If we look inside, you will find that all the let's say the domain logic, the main constraints, requirements of what is possible, what is valid, what is not valid, all the state changes are implemented just in these services. This approach is called an anemic domain. It's called, not sure if it's why it's called anemic, but it means that we have entities that look like they would be implementing the actual business rules, but they are actually just data containers, and the logic is in services. Okay, so that's not what we want. Although, it's not like this approach is completely wrong, right? This approach works really well for small projects, for toy projects, maybe for small services, but once it grows, eventually it leads to having, first of all, these huge services classes with dozens of methods that are very often completely unrelated. The service classes that have different responsibilities, because some of these methods are meant to be used by other parts of the application. Some of these methods are meant to expose some data for let's say, for the controllers or to serve for whatever kind of serialization. So this is definitely not the approach that we would like to have. So we will switch back. And let's imagine that we did our work with, and we talked to librarians. So we actually did the effort to develop the domain language. And then by talking with them, we came up with some user stories. And these user stories are not they don't maybe look like the user stories you see often, because what I often see as a user story is actually just a task. No, these user stories represent some actual things that user wants to do with the application. So we have a couple of user stories, and I will not read them out loud. I believe you can read them yourselves, right? In these user stories, there are some keywords that form or are a part of our ubiquitous language, right? So the librarian wants to register a copy of a book. We have a book, we have a copy. The book has an ISBN, and the copy has the barcode. It works in a way that when you buy a book, it has this little barcode like anything you buy just in the bookstore. So this is actually the ISBN, right? Each copy of the book will have the same ISBN. And ISBN is not just like some random numbers. It actually means something. There is a checksum. It can be valid, can be not valid. From the ISBN, you can also infer, let's say, the publisher's code and things like that. So another story is that a user wants to rent a book, and then a user wants to give the book back. We also found out that the librarians would have to do a lot of work by rewriting, like looking at the book, checking what's the title, and then typing the title into the system. But we found out that there is a third party, like an API, openlibrary.org, where you can search by ISBN, and it will give you all the information about the book. So this is how we will simplify their lives. Okay, so we have we could break this big library problem into two smaller pieces. One is that there is a catalog where people want to search for the book, browse the book, see what's there, see what's available. But then there's also landing books. And landing books is a little bit more complex process, right? Because if you give the book late, then you will have to pay a fee. This fee maybe it will have to be calculated somehow differently. I don't know. But if we would want to break it down into smaller pieces, it will be definitely a landing and the catalog. All right, so let's turn into the code and see how can we how can we implement it? I have here pure Spring Boot application. Almost pure, not like 100%. I added some dependencies, but there is nothing that you don't know. Has anyone been to Spring Monolith talk yesterday, today? Many of you. That's awesome. I think Spring Monolith is like the most important project in Spring portfolio since Spring Boot, maybe, or yeah, something like that. And the rest of the dependencies we have here are not so relevant. All right, so we want to develop the first module that will be a catalog. We are going to use monoliths for a very good reason. A lot of things about domain-driven design is trying to break things into pieces, create boundaries around things, because smaller things are easier to maintain. But the big problem is that it's very difficult to actually get these boundaries right. If we would use microservices, and if we get the boundaries wrong, it's very difficult to change it, right? Because we have data stored in the different databases. So you would have to do some very complex data migration. If you have everything in one piece, then it's usually just related with reshuffling classes and maybe writing some very simple flyway database migration, for example. So we have this library, and we will create a package that is called a catalog because we will start with it. And in this package, we will indicate that we have a domain. If you remember these rings, we had these outer rings, and inside we had the application services, and we had the, what do we have? Domain model, and then there was also an infrastructure. These rings are very good candidates to form packages. So we will start with the domain, and we will start with a very simple one. I mean, as I said, this domain is simple enough that everyone can totally understand what is happening. And we will start with implementing, whoa, what did I do? The book. So this would be like an entry point, but we know already that this is wrong, right? We don't want to have like a randomly mutable data structures. We want to build a proper class that represents what is possible to do with the book in the domain. So when we have this book, it has 3 fields. It has an ID, title, and ISBN. All of them are stored as strings. As I said before, ISBN is not actually a string. You can't just put there anything. It has certain rules, but also for the librarians, for the book industry, ISBN is a super important concept, and it deserves to have its own type. So let's create a record that will be ISBN. We will represent it as a record because we want it to be immutable, and it's a very good candidate for value objects. If you want to implement value objects, so these are the objects where we define equality by comparing all of its properties, the record is definitely the best choice. ISBN cannot be changed, so it's a perfect candidate. But it's not just like some container for a string, right? When we create an ISBN, we already make sure that you cannot create an ISBN with some invalid data. So if we go back to the book, now when we create a book, we don't have to worry about the validation of ISBN. In fact, in any other place in the application, we don't have to worry about it. Another thing is ID. In the database, we are going to store ID as a UUID. So this would be already a step forward, but we can do better. The common approach is to create a dedicated ID classes for each of the entity or each of the aggregate. And we will do exactly the same here. We will create an ID. I want to create a record. And this will be a book ID that is just like a value container for the UUID, but it also ensures that you don't do something nasty and create a book ID with something that is null. All right, so this will be our book entity, but we need to make sure that when we create it, and we create it by passing the title and the ISBN, we will assign the ID just by creating a new book ID, because this will generate a new UUID for us. We need to make sure that we do not allow any of the entities to exist in the invalid state. So we have to ensure that the title cannot be null, and also that the ISBN cannot be null. By the way, this new IntelliJ, this AI auto-completion is blowing up my mind. Really handy for presentations. All right, so now we have a book, and not unfortunately, I mean, in the end, we do want to persist it somehow in the database, in the data store. So the common concept for it is to create a repository. And repository is not like a data access object. It's actually a part of our domain model. The repositories act as a collection of aggregates or entities. So we will create a book repository that will have a method book, save book. And we have two options now. I said that we want to keep the domain model as pure and framework agnostic as possible. So there are people who say that the DDD entity is not the same as the JPA entity, and you shouldn't mix these two. In some cases, I agree, but I think there are cases where it also may not be true. So if we would like to make it as a not JPA entity, but still use JPA to persist it, we would have to do quite a bit of work to make it actually happen. Let me quickly switch in time to the future and see how this could be implemented, how the book repository could be implemented with JPA, but without touching the book class. So if we keep the book class pure. In the infrastructuring, because it kind of makes sense, this is like our implementation details, we would have to create a copy of the book entity that is pretty much the same. We just are here allowed to use whatever types we want, so the ones that actually Hibernate and JPA can handle, because Hibernate and JPA does not handle any type of Java types you pass there, right? So, and it's just a data container pretty much that maps to a table. Then we create a Spring Data repository for this book entity, and we have to introduce this mapping layer. So we have a JPA book repository that implements our repository from the domain, and when we save it, we have to do this mapping from book into book entity. And then we would have to do the same for fetching the data. When we fetch it, we will get the book entity, and then we have to map it into the book entity, but from the domain. If you see it and think like this is doesn't seem to be right, then I share the sentiment. JPA got actually pretty good in mapping records and in mapping different data types. We can turn this book into a JPA entity without really changing it too much. So we cannot use an @id annotation on the identifier that is implemented as a record, but if we use embedded ID, then suddenly it starts to work. It's with ISBN is similar. So if it's a record, we mark it as embedded, and then this is it. No, it's not yet it. Let's see if the test will actually pass. It passed, but it passed by accident. So the Spring Boot application is configured to create these tables for us. Of course, not something you do in production. It's we just do it for the demo purposes. So what happened here? It created a table book with 3 columns: ID, title, and the value. And something should be fishy, right? What is wrong here? You don't want to help me. So the value is not something that matches, right? We have ID, title, and ISBN. Where is this value coming from? The value comes from the fact that ISBN has a property value over here, and we definitely don't want to map it as a value in the database table. So what we can do attribute override and say that we want to attribute the attribute value from here map to a column with a name ISBN. So now if I run this test again, the database structure should change and we should get the ISBN colon. So this is our first entity. Another thing that we talked about in the user stories were copies of the book. So we will create another entity that will be a copy. We will also mark it as an entity. We will create a copy ID identifier, and this is actually exactly the same content, but we want to distinguish it for a very good reason. So we will have a private copy ID as an ID. We mark it with embedded ID. We said before that the copy has its own barcode. Oh, did I say it actually? Maybe not. So in the library, they paste their own barcodes on each copy of the book so that they can scan it with the barcode scanner and they can track each individual copy of the book. And this barcode will be just extremely simple. We will not add any validation, although maybe we should. We mark it as embedded. And then this copy relates to a book, right? So we have one concept of a book. Let's say this is the domain-driven design book, but in the library we have like 5 copies of it. So this refers to a book. If we would do it traditionally, we would make a reference to a book. This is like the typical thing that you do with JPA. You use the many-to-one annotation and have the reference to a book. This is not something that is advised when you're implementing domain-driven design aggregates or entities. If book as an entity has its own repository, then it means that it is a separate aggregate. And copy is also another aggregate. The rule is that they reference each other by IDs. Because when you think about it, you don't want to give such a big power to the copy entity that it can modify the book. The only thing that it is interested in is the immutable ID of the book it refers to. So instead, we do book ID. And also mark it as embedded. And now we have to do the attribute override. And just change it to book ID. So this is our mapping. The one thing that I forgot to mention, because now it looks too good. It looks too good to be true that we just have to no, it doesn't even look too good. Hibernate requires us to have the default constructor. So this is unfortunately what we have to do. This is like the violation that we do on the entities. This is how we have to bend the rules a little bit. But the good thing is that it doesn't have to be public. So if it's a package private, Hibernate is happy. But we know that anyone outside from this package will not be able to actually use it. All right, we have these tables now created. We have a domain model, and now we will see how can we implement the use cases. So the use case was that you can add the book to the catalog, and also register a copy of a book. So just to speed things up a little bit, and turn into future. The use cases, or let's say the services, are implemented in the application ring. And what I could do, and what I would maybe traditionally do, I don't know how to call it, it's not really tradition, but that's what people do, is to create these service classes. So there would be a book service, there would be a copy service, and they would have methods for everything related to book and everything related to the services. And I think this is really a good recipe of ending up with just a bunch of unrelated procedures that end up with super difficult to maintain classes, and also difficult to maintain tests. So what I think is a better way is to borrow a concept from clean architecture and implement it as use cases. And this means, like using simple words, that you take each method from the service class and put it as a separate class. So in this case, we have an application package, and we implemented register book copy use case as a separate class with just one single method, execute. And now, this is where already you can see the benefits of using the value objects. Since the book ID is not a string and the barcode is not a string, if I want to invoke this method, there is no chances of accidentally flipping them. Great, okay. Let me turn a little bit more in time, or maybe not. Okay, let's create another use case, and this use case will be add book to catalog use case. So this use case will also have a public void execute method, and where we create it, we will pass just ISBN, because we said that there is a service, third-party service that we can use to search for books by ISBN. What is the proper place to put it? It will make an HTTP call to some external service, so I believe it would make sense to put it into the infrastructure package. So if we create here something that is called a book search service, and then we also have to create some class that it returns. So this is like a relatively simple service that just using REST client goes to some service and then it returns a record that maps to a JSON that the service is exposed. So I can now go to my use case and do book search service and search by this ISBN. And we created now something that is really wrong, because we violated the arrow of dependencies. Suddenly we made the application depend on the infrastructure package. So what should we be doing instead is do it the opposite way. The service from the infrastructure should depend on something from the either domain or from the application. I will create an ISBN search service that will return, let's say, a book information. This will be also a part of application services, and it will have a search by ISBN. And this will be a record that just has a title. Why I put it in the application and not into the domain? Because this service is not really a part of the domain. This is not the result of the discussion with librarians about how a library works. It's just our initiative, our convenience level, let's say, layer for the librarians so that they don't have to copy it. So this is a part of the application. Okay, and now we make this book search service, implement the ISBN search service, and instead of returning this, it will return a book information. So we have to refactor it a little bit and return new book information where we pass the result title. And now these classes are not even, oh no, are they? They are still, right? We have to change it here that it uses ISBN search service, and then it searches by ISBN, so it returns a book information. We can do book repository, save new book, where we pass the book information title, and then ISBN. Okay, so these classes become completely an implementation detail. Whoa, not expected. What is happening here? Okay. So these classes should not be referenced by any other layer than maybe potentially the infrastructure, and we can and we should make them package private. So the pattern that we use here is called dependency inversion. In practice, in runtime, we still depend on the thing that happens in the infrastructure, but from the point of both the compilation, but also like a logical what depends on it, it's the other way around. If we decide to change the search service for some different provider, we don't have to suddenly change anything in our use cases because this record that maps to a JSON structure doesn't leak anywhere outside of it. But we have now 10 minutes left. But we have now a little bit a confusion, right? We have a service annotation over here, and we have also service annotation on the book search service in the repository, in the infrastructure. So Spring provides us these couple of stereotypes annotations. There is a repository, there is a service, there is a controller. And luckily, we can create our own building blocks. So we could say here that this is not a service, but this is actually a use case. And we can create an annotation like that, make it that it's a retention runtime, and then that there is a target type, and then meta-annotate it with a service annotation. In such case, we annotate our use cases with a use case annotation, and we can add some extra behavior to it. For example, we could say that we want this interface to be validated, and then we can use the validation annotations on these methods. We could also create some AOP aspects that can be specific to, useful for use cases. So we could create an aspect that will measure the method execution time, add some logging, or we could write an RQunit rule that will say that you are allowed to use only use cases from the web layer of the application. Okay, let's again move a little bit in the future, and we have here. We have now already implemented a second bounded context, so the implementation of another domain, which is lending. And in lending domain, so this is where we rent a book or we return a book, we have a loan. We create, when the book is rent, we create a loan. And here we track also, when we create a loan, we ensure that all the data is set properly. If you look at these use cases, they are usually trivial because we moved all the setters, all the potential ifs and everything into the domain classes. So when we create a loan, we already say that what is the created date, what is the expected return date. If the loan is returned, on the other hand, we check if it's returned after time or not, and if it's not, or if it is, that's my fate in Barcelona. Where is Tom? Oh, okay. It's not like I have a lot of time to do this stuff. Does it bring your childhood memories? I will mirror. Okay. Oh, if this brings your childhood memories, what about this one? All right, so we have these entities. This is like the most annoying thing to do. It started to pop up. All the constraints are in the domain and in the entities. That's what we at least try to do. But what if we have this renting the book? We need to ensure that the same copy is not rented twice. So the natural thing to do would be, and I have already on the repository method is available, and it takes the copy ID. So I would do loan repository is available, copy ID, if, and so on. You know, get my point, right? But this is a little bit problematic, because then we moved the domain rule of renting a book that is available, only the book that is available, from the domain layer or ring into the application. So what we could do instead is that when we create a loan, we can pass here a loan repository, and on this level we can ensure that loan repository is available, copy ID, and so on. And in such a case, there is no possibility that from any other point in the application, any other use case, any other thing that someone who joined your team 3 days ago and you are on holidays and he suddenly pushes it, can actually violate these rules, right? So I think it's quite handy, and it's quite different from what we tend to do normally. All right, whoa, I need to move forward. Okay, so let me take it a little bit back. We have these two modules, and we now they are very nicely separated, right? We are super proud because we built two separate concepts into two separate modules, but we know that it's always easy at the beginning, and then eventually it falls apart. So to prevent it from falling apart, we could use the module verification from the monoliths. We create application modules. We said that we want to do it for the whole application here, and we just call, whoops, what do we call? We call verify. And then I run it, and the test should pass because I believe I did not violate any of these rules. But if I would suddenly, surprise, surprise, what did I do? Module ending depends on non-exposed time type copy ID. Ah, okay, sorry, I messed it up. This should be wrong copy ID. But at least we have a proof now that it works. There are, though, cases where these modules do have to interact with each other, and they usually do have to interact somehow with each other. Let's say in the catalog module, we have to start tracking if the book is available. We are not really interested in who owns this book, when is he going to be returned. It's just about being available or not, so that when someone browses the catalogs, he can see that is there any copy that is available. So we have this book available. We could expose a setter, but we will not. We will do make available method, because we put meaningful method names, and set it to true. But how can we tell from the landing module that this book is actually available when the return use case is called? The worst thing that we could do is to do the copy repository, fetch the book, and change it and then save it. This will create like a very hard dependency on the catalog module from the landing. We could do something totally different, and also at the same time much better. So what we can do is we can make our entity, which is an aggregate, extend an abstract aggregate root from the Spring data. This abstract aggregate root has one very important capability. It can register events, so that whenever happens something in the entity, you can trigger the event. And in this case, we say that the loan was created or that the loan was closed. These events are not published actually here at this stage, but they are published when you call a save method. So here it will register that there is an event to publish, and then when you call a save, it will be published. And then in any other modules, you can listen for this event. So this changes the dynamics. The landing module doesn't know who is interested in these events and doesn't care who is interested in these events, and also doesn't really care if this gets executed or not. This is not its responsibility. But the catalog module can listen for the events with the application module listener, and then also execute certain actions on these events. This application gives us also guarantees that even if anything would fail here, eventually it will be executed. So this is a perfect combination for implementing something that is called eventual consistency. Okay. Six years ago, at this very same conference, was a talk with almost the same title. I noticed it a little bit too late. This talk is run by Michael Plut, and he's like a well-known domain-driven design expert, and he knows definitely more stuff than I do. And he approaches this topic from a little bit different angle. He explains a little bit more of the theory, and I would very strongly recommend that you watch it. It's like 50 minutes packed with knowledge. Then another thing, there is a 3 hours long workshop on Spring Monolith, where Oliver explains not only monolith, but also other concerns you should have when you want to properly architect the application. And I would kindly ask you for a round of applause for Oliver, who is not this year here, because pretty much when it comes to technical implementations and frameworks, everything that I use, the abstract aggregate route, the monolith, the Spring Data repositories, it's either him designing or implementing it. And this will be it from my side. Thank you very much.